Yeah. The start of that camera, it always reminds me of Mario Kart. My sister and I, we got a Mario Kart Wii like about when it was released, and Mario Kart was the game. I spent hours. Yeah, I got really good at that game. I never used. I hated using the steering wheel. I always used the nunchuck. You attach it and use it. It was way better. Yeah. I never had that, so we only had the nunchuck. But yeah, good times. So for today, you guys, one thing I want to try is get you guys signed in with. So you guys know, I mentioned having an AP account. Was everyone able to get an AP account? So if you guys get your MacBooks out, I'm going to show you like our course page and have you guys join it so that you guys can get access to that. Do you have a question? Okay. You might be able to just do it now. You can, I'll go a little slower, but try and just make an AP account. Do you have one already? No? Okay. Go ahead and just go make an AP account. I would just like Google like AP login or AP account, and there'll be a link. If it asks you for the login, there should always be a button like don't have an account, create one, and then just create one. Because you'll need it regardless. You'll need that AP account for when you register for the test if you take it. Otherwise, that same account we're going to use. I'm going to give you guys access to like myAP Classroom. It's AP's Classroom. It's not necessarily like a class page like Google Classroom. It's more like a big like resource and question bank that you guys will use. And we'll also do a little bit, I'll either do practice problems through it or we might do homework through some of the problems that they have on there. But it'll be a really big resource. So, there's engineering. Oh, I need to. Is that too dark? I just want to brighten that up. Do you have a question? Yeah, you can go ahead and create one now. Like it shouldn't take you too long. Um, just Google like AP account or log in, either one. But you'll have just they'll log in and then they'll always have that an option. Don't have one create. Are you sure you don't have one? Try logging in. I must have autofilled wrong. Yeah, just be creative. And it shouldn't take you too long to get behind this call. Oh, right. Huh. So you guys are already in. Okay, sweet. Yeah, again, try to make that massive. That way you can see it. So if you guys, once you're in, I'm not sure where the page is. There should be. It'll ask you to like log in to the course or the class code. That's the code for like our classroom. and that should let you in. I haven't seen it from the student end. It should be pretty obvious, hopefully, where to put that code in. I know a couple of you guys figured it out. Yeah. Is that part of the setting?
No, it just popped up when I was trying to sign up for the course.
Go ahead and fill that in as best you can. And again, this is a learning experience for me to see what it looks like from your guys' side. So this is for the myAP account. When you log in, you'll have access through that account to like a classroom page for this. This is the access code to get into like the classroom that I've set up. Again, it's more a resource for you guys. There'll be a lot of like studying resources, and then a lot of like questions, so you can like make your own quizzes on certain topics or units. There should be at least one full practice exam. So when we get towards test date, you guys can go in here and kind of simulate a test. That way you get like as close of experience as possible with what the test will be like and kind of what the questions will be like, whether they're the multiple choice, the free response, things like that. But I want to at least get you guys connected and into this so that you have access if you need it, specifically to our classroom page that you'll need to connect to. Does anyone still need help getting logged into our specific course page with that code?
Which nuggets did you get? Did you get the spicy?
Did you get?
There was regular and spicy.
I
Okay.
can't trust the school with spicy things.
One of my classes, I think it was my success hour, they were complaining that, no, engineering, I think, that they didn't have ranch when they first had the spicy chicken sandwich.
Oh yeah.
They were all mad. They came in heated.
I forgot to ask for ketchup, so I was.
Does anyone else still need help? If not, I'll write that code in case you'll get to it later, but. Okay. So come on. So most of you guys should be into that classroom. Are you in it on yours? What does it look like from the student?
What I'm gonna do after college, or probably.
Yeah.
But it's, I don't know why it's doing that
Hell yeah. I'm not doing that.
Go back one.
Scores.
Yeah. I mean,
because that's where you sign up.
Oh,
Should I
yeah.
check
So then go to this AP classroom. That should be the.
That's where you like.
Macaroni in a box.
Yeah. Yeah. That looks like it. Can I have you try sharing or connecting to the AirPlay so that I can see the student? Look for Heinz Lane.
Oh.
Hopefully it asks you for a code. So I'm going to have Maggie log in and put it on here so that way we're working from the student view rather than my like teacher view. Oh, this will be really annoying. If you go to settings, display. I know, that's what I'm changing. On the AirPlay, if you go to scale
Yes.
and then pick 720, won't make things as high resolution. Everything will be big.
Okay.
That way you can X out that, and then we'll all be able to see better. Sure, that's what they all said.
Literally.
Yeah. So this is Maggie's screen. We're going to use this to kind of go together and see what you guys are seeing. Just so that you guys have an understanding of what this will be and how to use it. We won't really use it like as a key part of this class or a part of in-class stuff. This is primarily a resource for you guys. There might be times that I think I can make quizzes and assign them through this. So I tell you guys, like, hey guys, I made a quiz, a practice quiz for the end of this unit. Go into myAP Classroom and you'll find it. But predominantly, there are a lot of things that you can just do and use on your own. So this is like, I think this is the science practices that I put in the syllabus. It's just kind of general info. So if you click on this first one, I'm curious what it'll look like for you guys. So yeah, so the science practices, that diagram I had sideways, this I think will break down all of those, kind of explain very in lengthy detail what it is, and then the specific, if you scroll up a little bit, these are like the specific, characteristics of that general practice. So that, again, just a resource, just information. You probably won't use that directly. So if you want to go back one, go back to this. The rubrics, I haven't seen this one. So this is your guys' student view of the rubrics and the different standards-based for when you do a lab report or do data analysis or something. Just more description, and I think specifically for the practices. If you scroll down, is it just list? Yeah. So it goes the practice by practice. All those different science practices on the previous document, it'll break those down. Again, I don't think you'll actually use this much. This is just a ton of information, but that's there if you need it. Okay, so if you go back, there shouldn't be any other resources. So go to Unit 1. This one should, so again, 10 units. It's structured very nicely for the class. There are 10 core units that we're going to get through. So it's nice and kind of sectioned. Do you have a question?
Yeah, that might count.
Okay. Did you need the code? Yeah, so the code, if you can see it over here,
Where do I put it in?
it should ask you, I think, to join the classroom.
Well, I already had an account.
Okay,
But I got back in.
that's fine. As long as you're in, this guy. So join your AP classroom. I'll probably ask you to log in again. And then get started. Yes, yep, and that'll be that. Should ask for that code. That'll get you into kind of what we're looking at here. And then it's like the myAP Classroom link. So again, I haven't used this from the student's end. Click on topic 1. Can you click on that at all? No? So then down here in this progress check, is there anything below that? No. So here, try these. Are those locked?
Yeah.
I wonder if I have to. Yeah, okay, so there's a lot of stuff that I can set up on my end. Okay, so there's a lot of things that I'll have to do on my end to kind of open that for you guys. And I'm still learning how my side works with your guys' side, like what you see. Okay. This might kick you off, but. So this will be what you guys will be able to access once I have to set them up in a certain way before it like is unlocked to you guys. But this is something that you guys might see as they call them progress checks. It's basically like a mini quiz for that unit to see like how you're understanding the material. So this would be, a question 1. You release this rock. Short time later, the other one's released. So you got to pick which graph shows vertical velocity for rock X. So this would be an example of, again, a multiple choice question. That's the MCQ. And then they have this all set up as like practice quizzes for not only unit review, but also give you a bit of a format for like what would an AP question, like an exam question, look like, how they word it and all that stuff. So those are things that I'll probably take advantage of. For you guys, what would be most useful for that resource? Again, there would be multiple choice questions and free response questions that will be practiced through this. Would you guys like those as like a part of the homework where I'm going to make them assigned and worth points? That way you do them as like a part of the homework for this class. Do you want them not to be graded? I don't need to grade them. Do you want them participation? In your guys' head as you not only plan and learn in this class, but also plan for the AP test, what's the best use of this resource? I want to get your guys' thoughts. Absolutely no thoughts? Okay, well, I'll decide then. I'll think through. One, I got to learn how I assign them. You have to make this quiz and then assign it, so I'll figure out how to do that and how I want to do that. But yes, I wanted to at least show you guys this. The other tricky bit that I kind of wanted to ask you guys about, there's a lot of like note sheets and workbook problems that AP has available. Is it something I wanted to ask? I'm trying to avoid printing out a bunch of stuff just so you guys have copies of things to do for when we're working in class or doing problem solving. There's a PDF of that kind of work set. Can you guys edit PDFs? Because like if I convert it to a Google Doc, it looks like absolute gibberish. Have you guys? Huh? Okay. No. Because I know you can edit it in, like in Mac, you can do the preview and you can do markup and you can place text boxes and fill in text. Is that something that would be a hassle? Yes? Okay. I figured it would be, but I wanted to ask. Again, my point I was trying to avoid, because this is like the actual workbook, if I gave you everything, let's see. This guy is 358 pages. So to give you guys a PDF of that would be easy, and then you guys have access to everything. But the point is to like there's practice problems. There's like mini labs built in, things like that. Huh? No. It's not a textbook. This is from AP. That it's like one of their provided resources of practice problems, like guided practice problems when you introduce concepts. So an example. So if we're looking at Unit 1, Kinematics, which we'll be starting, they have like really basic intro scenarios, walking you through, looking at like displacement. Then they get more complex. So it's worksheets, guided practice, things like that. So I figured it wouldn't really work to have you guys edit them, because again, it's a PDF, it's not a Word doc. So this one, I'll likely pick and choose and do things that are necessary, and I'll print those out for you guys. For those of you students that are watching this virtually, that might be something where you can let me know if you have access to a printer. The days that we do these, you can print out the specific page, and I'll mention that. Otherwise, we can be in touch about how to do that virtually. So that was one thing that I wanted to at least ask you guys about. So, okay. I think that's all the bookkeeping stuff. Again, did everybody get their AP account? And everybody got that join code to get into the classroom? That way you have that, and I'll figure out how to get those sent to you guys. Because I think I have to unlock them individually, like you couldn't access it. I like open it for you guys. And then you'll have those to do. Yeah, that's all the kind of bookkeeping things that I didn't know how long it would take, but wanted you guys to at least see. So I'm going to get this turned off. We'll start Unit 1 today, just basic. Introduction. How many of you guys have taken a physics class before? No one. How about like integrated chem physics? Has anybody taken that? Because the second part of that's physics, physical science. How many of you are like really new to physics in general? Okay, quite a few of you. Okay, that's all right. That's good for me to know, especially when we start. Unit 1, kinematics, is just motion. And so that's good to know from my end. The first main part of this unit is going to be 3 main topics: position, velocity, and acceleration. Those are the 3 basic concepts that we use to describe motion in general. If I draw this, draw this graph, make sure that's showing up. When I draw this graph, what do you guys think this is telling you? You guys might not know that, and that's okay. I'm starting from scratch and seeing, this is kind of one of the starting points that we'll do. What do you think this graph is telling you? And explain, don't just tell me, but explain how you know that, or how you think that. Yeah, Ethan.
Time in seconds and distance in meters?
Yep, that's exactly right. So the axes, to interpret what these mean, I could rewrite in a more explicit way. Because he's exactly right. That was like the shorthand for those are exactly the same. What this is a position time graph. So those three concepts, position, velocity, acceleration, this is the start point. When we look at any sort of motion, the kinematics of something, the most basic thing is looking at its position. When in this class, we will almost always use the SI units. So meters, seconds. This is in comparison to feet in like English units. We won't use that. We'll use kilogram instead of pounds. And then there's a lot more, but that's just to kind of prepare you. We're not going to use really pounds. We're not going to talk about feet. We're going to use the metric system. So meters, kilometers, micrometer, all those things. There's, in English units, we talk about pounds, talking about like I weigh 200 pounds. When you convert that, people always go to like, oh, the metric unit for that is kilograms. They're actually two completely different things. Does anybody know why these are completely different and not really supposed to be something you convert between? I don't expect you to know. I was just curious if anyone did. You guys remember from like...
Is pounds weight and then grams mass?
Yes, exactly. If you guys remember from chemistry, when you talk about what mass is measured by kilograms. Kilograms is how much matter is in something. So if I have, say, 100 kilograms, if I am 100 kilograms, my mass is the exact same if I'm on the moon. I still have the same amount of matter to me, but my weight is different. I weigh less on the moon than I do here. So this would really be the measure of how much I weigh in a physics class when we use the metric system is newtons. It's a force. A weight is how strong the pull of gravity is on how much mass you have. So pounds is the US version of weight or force in science class. So that's just a little tangent. Coming back to this, that's why I have meters, not feet, which you would probably think of as the typical position unit, but we use kind of the metric system. If this graph says at any given time, this is my position in meters, can you tell me what kind of motion this object has if it's a flat line?
None.
Huh? None. Why do you say none?
Because the amount of time that goes by, it hasn't moved.
Yeah.
It would be moving upwards. More distance.
Yeah, exactly. This means, this is your 0 point. At time 1 second, my position is, we'll say, 10 meters. If I fast forward in time and go to at time 10 seconds from when I started recording, my position is still 10 meters. So if I change this and I draw a different position time graph, what kind of motion, how would this look like in real life? So you were saying throwing something. Does my position change evenly for every given second? Yeah. Do you guys remember slope? I don't know when you would have first been introduced to that. Pre-algebra, probably. So, one thing that you can calculate is from a position time graph is velocity. If I go from 0 seconds to 1 second, I can say my final minus initial time in the denominator, my numerator, I'm going to look at how my position changed. Say this is 3. I do final position minus initial position. What is the units that we measured position in? Meters, little m. Seconds. So this is a really key concept that should be fairly straightforward. If I look at the change in my position, how this changed versus how it changed in time, all that is the slope of the line. What is this quantity? The math told us it was 3 meters every second. Well, what is that? Does that ring a bell? Is that another quantity related to motion that we know about? If I say the 3 main topics that we're starting with for kinematics, for motion, is position, velocity, and acceleration. Velocity. And again, I'm not expecting you guys to know this. I'm just showing you ahead of time and then explaining that velocity usually say average is displacement over time. Displacement is what we calculated. We looked at how your position changes. If I can move this over. This is another term. Displacement is the change in position. I forget his name. Evan? Are you paying attention? So, displacement, all that means is how did your position change? The way you calculate that mathematically is what was the final position minus the initial position. Hopefully you guys have seen this triangle before. How many of you have seen that before? Delta, that just means change. Change in X. Whenever you see that, change in blank, do the final minus initial. But that's a shorthand notation that we'll use a lot. So when we have a displacement, we have a change in position. That previous example, this guy, when I had position in meters and time in seconds, what's the displacement of this motion? 0, right? If I did delta x, I want x final minus x initial. If this is 10 meters, say 1 second, 10 seconds, my displacement, I do my final displacement minus my initial. So I'm going to do 10 minus 10. Does that make sense? If you are given this and asked for a displacement from between times 1 and 10, the displacement is how your position changed. Now, if I change the position time graph, I want to do the same calculation. What's the displacement from time equals 10 to time equals 1? I do my formula. I know displacement is the change in position. My final position was at 2. My initial position was also at 2. Oops. My displacement was 0. That's weird, right? Because my object went all the way up to 10, not exactly, and then walked backwards. But displacement is only looking at 2 points in time. So this would be like me starting here. I walk forward at the same speed, and then I immediately go backwards. At these 2 points in time, I'm at the same position. So if I took a picture at time 1 second, and I kept walking, and then I came straight back, took a picture at 10 seconds, my position is exactly the same. So I haven't displaced anything. This will be hard to remember because when you look at this, if it asks for displacement, you need to know your start and end points. Because you know there's stuff going on. It's not an object at rest, but you need to know what is it asking you for, and then just using this. Now, when we ask for the velocity, the average velocity that's looking at, for a given amount of time, what was my average speed? Well, you can do that by doing the displacement over the time. So if I were to do average velocity, we do V average. How do we do that? For between 1 and 10 seconds. Delta x is displacement, right? How do I calculate a displacement? It's the x final minus x initial. Delta means final minus initial. So what was my final position? What was my initial position? Huh? 2. right? So I have 2 minus 2. What was my change in time? What was my final time? Initial time? 0 meters per second, right? Position is measured in meters, time is measured in seconds. So my average velocity was 0 meters per second. Does that make sense? Why? I displaced 0 meters between those 2 points. From time final to time initial, I didn't go anywhere when you compare the two. Even though there's 10 seconds, 9 seconds between the two, 0 divided by anything is 0. So on average, between these 2 points in time, I averaged 0 meters per second of motion. The tricky part to remember, between those points, I was moving though. Do you see the difference? When I do the average velocity, it's just looking at 2 points in time and saying on average, I was moving this fast. What actually happened, according to this graph, is I was walking and then I immediately went back the other way at the same speed and came back to the same point in time or the same point in position. So how would I figure out how fast I was going at 1 second? You know, you start timing and I start walking. After 1 second, how do I know how fast I'm going at that exact moment? At this point right here. Huh?
You're not moving. If you're at that exact moment, you aren't moving.
Okay. You're right if you froze time, but it means at 1 second, if I watched you at 1 second, how fast would you be going? So you're not freezing time, you're just looking at a specific moment. Because at time t equals 0, if you looked at that picture, you haven't started moving at all, you would be at a standstill. It's kind of like you think about the picture, like high-speed cameras, you know, it tries to take a picture but it looks blurry. That picture is a frozen moment in time, but that vehicle was moving at a certain speed. It's blurry because it was going so fast. The idea is you're looking at a very specific point in time, and you want to know how fast I was walking. How do I figure that out?
Isn't it distance over time?
It is. And that's like the basic definition of velocity. Velocity is the change in distance over the change in time. But we want to know at one specific moment. How do I know my change in distance at this moment? How do I figure that out? Again, I'm not expecting you guys to know this. I want to pose this and let you guys ponder. If I mention slope, do you think we could use that? We'll just do this. I want to know how fast I'm going at exactly this point in time, what I would do is I would learn the slope, or figure out the slope of the line at that point. So if I look at this position time graph and I find the slope at this point, that'll tell me how fast I'm going at that moment. You guys remember how to find the slope of a line? Rise or run. That's how I always remember it. So if I want it at 3 seconds, my line, it's a straight line. So I can just make a triangle out of it. What's the run? I'm going to go from the origin, since I know that point's 0 seconds, 0 meters. 3, right? Three what? 3 seconds. 3 seconds minus 0. That length is 3 seconds. What's my rise? This leg of the triangle? 6. 6 what? Meters, right? The other axis is measured in meters. What that means is at that moment in time, my object is traveling at 2 meters per second. If we looked at the other example, I'm just going to roughly draw it. Remember the one where we had this? And we had 1 and, say 10. When we calculated the average velocity between 10 and 1 second, it was 0, right? When you do average velocity, you're looking at displacement. The start and end position was exactly the same. But if I look at the velocity, the instantaneous, that's what they call it, at 1 second, is the slope of that 0? No. It's positive something, and we could calculate that. What about over here? Is the slope of that line 0? But wasn't our average velocity 0? It was. Average velocity is approximating how fast you are going from the start and end point. Thank you. And it's defined by displacement. Displacement is based on a start and an end point. When we do velocity instantaneous, you can sometimes write it like that. That's looking at one moment in time, how fast is that object going. That's when you need to look at the slope of a line. How many of you guys have taken calculus? Taking it? How many of you guys have taken geometry? Hopefully all of you. Did you guys do tangent lines? Yeah? You what?
Tell me we're not using them.
Kind of.
Aren't you sorry? I got dropped out.
What if my position looked like this?
I would cry.
Isn't like a
And, okay. So I'm going to ask you the same question.
Would that just be like X squared?
What's my average velocity from between times 10 second and time t equals 1 second? 0. You know that already because you know the average velocity, you need the displacement, which is basically the final position minus the initial. Final position's 1, initial's 1. 0 divided by anything is 0. But if I ask you, what's the velocity at time t equals 1? You don't have a line, you have a curve. Right.
But I don't think I ever, we never like.
And I'm not asking you guys to. This isn't a calc-based class. It's a calc concept because what you would do, just so you guys know, you would find the derivative of this function. When you take the derivative, plug in whatever point you want, that'll tell you the velocity. Because a derivative is the slope of the tangent line. You guys won't need to know that. What you guys need to know is if I need the instantaneous velocity, I need the slope at this point. If it's already a line, the slope of that line is the line itself. But if it's a curve, I got to take a line and basically touch it to a curve at one specific point. If I want the slope of that line, which would be the instantaneous velocity, I'm going to do a straight line. I'm not going to do it very well. And I'm going to touch the curve at one point. That slope would be the velocity at that moment in time. Does that make sense? It's okay if it's confusing. I'm throwing a lot at you. I just want you to see a lot of these connections. And we're going to do a lot of things to kind of get into this and kind of explain and practice how to do this, even though this is kind of a lot. How are you guys feeling? Again, this is first introductions. I mean, you know, even within one day that you're seeing the material. You'll see it more and more and get a lot more comfortable. But I wanted to explain some of these basic terms and what they mean, and at least show you how you can do those. And hopefully I'll be able to, I know there's a lot of physics stuff that's still in Mr. Cunningham's room. Since he was in this room and then they switched, there's still a lot of equipment that I need to get. Hopefully we can get that soon and I can get a lab set up because you'll actually use those ramps. You'll actually put like a cart on them and you have a motion detector that will record the position of that object, and you'll be able to make graphs based on how you move your cart. And then you'll be able to use that data and actually come up with things. You'll be able to calculate, well, how fast was it going, you know, at the top of the incline or something. You can use the data that you actually collect to do all that based on what you know about all this stuff. We'll get there, but I just wanted to get you a little preview of what that'll be. That'll be a really cool one and help you connect the dots between kind of the basics of just motion. So I want to come back to displacement a little bit. So displacement we talked about. Brody, I think this was from you from the office. As I write this, displacement is oftentimes S. It's a little misleading. Yeah, I'm not a huge fan of it, but
What's speed?
huh?
What's speed?
Velocity, so they use V, which is much more intuitive. This is the oddball. Does anybody know what these little half carrots or half arrows are?
I remember seeing them, but we saw them in like chemistry. I thought. Were they doing chemistry or am I just?
Yeah. In the chemical reaction, you can have like A plus B. They'll either do an arrow. Sometimes they'll do.
Yeah, I remember.
Yeah. So in chemistry, this means like it's a reversible reaction. You can mix these two things to get C, but you can also do something to C, and it'll break down into A and B. It goes back and forth. Sometimes they write it like this. Sometimes they do the full arrow. Does the word vector ring a bell? Vector? Are you talking about Despicable Me? So he's actually
direction
and magnitude. Yeah, in Despicable Me, that's the literal definition of what a vector is. A mathematical quantity with both magnitude and direction. Now, what does magnitude mean? If I say a quantity has magnitude, what am I actually saying? Okay, how about you've heard it related to earthquakes?
Is that like size or something like that?
Exactly.
I think they're just.
If I have the Richter scale is 0 to 10. I'm not 100% sure, but if you have a 6.0 magnitude earthquake compared to a 1.0 magnitude earthquake, which earthquake is bigger in size? The 6. The magnitude in math and also in physics is the same thing. It's literally the quantity. How big is the number? So is the magnitude 100? Is it 2? It's just how big is it? Direction is the big thing that if you just have a magnitude in math, they call that a scalar. That's a scalar. It's just a number. It's just a magnitude. What? It is a 5. It's supposed to be a 5. How about, make sure. There. It's an 8. That's a scalar. It's a magnitude. It's literally just a number. It's just a size. This isn't useful in physics. This doesn't really tell us anything. But if I say mile per hour, that helps. This now tells me the units. That's the unit. If I told you my car is driving 8 miles an hour, would you know where I'm going? Why? Yeah, that's the direction. If you add a direction, you know more. So if I say 8 mile an hour northeast, that's a magnitude and a direction. This is now a vector. If I'm telling you that displacement is a vector, what does that mean for the change in position? I need direction, don't I? If I tell you an object was displaced 10 meters backwards, time 10 meters backwards, basically be, oops, not like that. It'd be like this. Let's say this is time 1 second, 5 seconds. This will do 10, 5. How do I do my displacement between these two times? Well, time is the easy one. What's T final? T final minus T initial. What's my final time? Time always moves from 0 onward. Final is 5. What's my initial? Okay, now I need to look at my displacement. My final displacement, what position am I at? 5 minus my initial position. Initially I was at 10. Right? 5 minus 10 is negative 10, or negative 5. 5 minus 1 is actually 4. So this is wrong. Already done. That's my displacement I calculated. What are the units of this displacement? Just look at the basic fraction. What are the units at the top? Meters over seconds. This is actually not displacement, right? You guys see the mistake I made? Velocity average is the change in position over time. This is S, or the displacement. This is the displacement. I'm just dividing it by the time. So when I get my answer, that's my average velocity. When I found out that my displacement, the change in position, was negative 5 meters, the negative is the direction. If I just wrote 5 meters, that's just a number. It's just a scalar. The negative indicates direction. What is that direction compared to the motion that we defined it as? If I say it's negative, what does that mean? Backwards. I start, if this is my 0 point, I start over here, and I start timing, and I get closer to 0, where I'm measuring from. That negative sign is the direction. Not only the direction of the displacement, your position is moving backwards, but now when you divide by time, your average velocity is negative, which means your average velocity is backwards. Because we defined this is 0, that's, positive infinity. I start somewhere over there, and as time goes by, I move closer and closer to 0. So when I calculate the average velocity, on average, I move backwards 5 seconds 5 meters every 4 seconds. That makes sense? So when you hear the word vector, think of Despicable Me and vector, mathematical quantity with magnitude and direction. I need a direction. That negative is my direction because I already said this is 0 and everything away from it in this direction is positive. What happens if I go like this? Now what do I do? Now I need to go, say this is negative 2 meters. What does negative 2 meters mean? Huh? Not quite. Again, I just said, I start at 0, and I say forward is positive. Or backwards. What this actually means, this motion in real life means I would have started somewhere ahead of my 0 point. If this is my 0 point, I'm going to start away from it, and I'm going to move towards it. Yeah, I'm going to get closer to 0, and then I'm going to keep going, and I'm going to go in another direction. This is the negative x direction. That's negative x direction, that's positive x direction. Whenever I see a negative number, that tells me the direction. I'm going towards 0. My position's getting closer to 0, or it's increasing in a negative direction. It's okay if that feels a little like trippy, because it kind of is. It's really weird. Especially when you're trying to describe motion, things that you can watch, but now put it on a graph and make the graph tell you what the motion's doing. It'll be kind of weird. You kind of will learn how to interpret between the two. You'll learn how to see motion and be able to make a graph of it, or figure out what that graph will look like. You'll also be able to do the opposite. If I give you this, you should be able to tell me what would that look like in real life. Does that make sense? Again, it's okay if you're overwhelmed. I'm throwing a lot at you. I want to throw a bunch of this stuff out, and then we'll break it apart piece by piece. But this is just a lot of basics. I throw a lot of terminology at you. I don't expect you to memorize it, but we'll go back to it piece by piece, and we'll work through, do practice problems with, tell me the average velocity based on this graph. Also based on this graph, tell me the instantaneous velocity at blank time. You'll be able to do all those things and figure them out based on, we'll learn a lot more, we'll practice recognizing all these terms and what that it's actually asking. We'll do practice problems calculating these things, getting sample graphs and seeing what that looks like. That's kind of all I want to go over right now. The last thing I'll say, velocity. Velocity is I'm going to give this to you guys in advance, and then we'll come back to it later. This would be, technically if we write it this way, we'd have to put average. The actual definition of velocity is the rate of change of position with respect to time. Translation, how does position change over time? That's all velocity is. How much your position changes with time. The mathematical way we write that is displacement over time. Displacement's a vector. It has a direction. You need to define a direction in order to have an accurate displacement, and therefore the average velocity is also a vector. You're traveling at 5 meters per second or negative 5 meters per second. It needs a direction. I'll pull this back over and actually write the same type of sentence. So So hopefully you guys see the parallels. Again, we're going to get to this in a bit, a couple classes at least. Velocity is the rate of change of position with respect to time. I look at a position time graph and I see how that changes over time, tells me the velocity, how fast something's moving. If I look at how fast the velocity is moving with respect to time, that's an acceleration. They're parallels to each other. Velocity is how much your position changes with time. Acceleration is how much your velocity changes with time. Meaning, initially I'm going 5 meters per second, and after 5 seconds I'm going 10 meters per second. My velocity changed by 5 meters per second during those 5 seconds. That's acceleration. It's also a vector. Is your velocity getting bigger, more positive? Is it getting smaller? Or is it getting more negative? So it has a direction because velocity has a direction. They're all vectors. This little arrow is to represent, that's a vector quantity. So I just wanted to lay that out there. I don't expect you guys to know that, but while we're on this topic, I wanted to show you the similarities, and we'll get to kind of the pattern between position velocity and velocity acceleration. Sorry if I'm overwhelmed. Yeah, it's okay if you feel overwhelmed. We'll break all these parts down. If you guys have any questions about this stuff, and that was a super quick introduction. Is there anything that didn't quite make sense or you wanted me to go over and say again? Anything? All right. We'll pause there for the day.